Hello friends, welcome to this next episode on the topic MCQ in mathematical logics. We have been seeing MCQs in the last two videos. We covered on graph theory and group theory. This will be the one next in the series which will talk on the frequently occurring MCQs using mathematical logics. Not to just limit to these few things, we will also discuss on the generality of the statements that can happen over here in mathematical logics, so that we will be able to answer any sort of questions. Come on, we will get started. The first question asks, what is going to be a premise may be introduced at any point in the derivation using which of the rule? There are going to be two rules using which a premise can be introduced, and a premise can be tautologically true from one over the other. They are referred by the name called as rule P and rule T. So rule P helps us to introduce a premise. And what does rule T do? It says two or more statements which have already been proved for can be implied tautologically true from two or more statements above. Two or more statements which have been solved in the previous stages. So rule P is for introduction of any of the given premises, and rule T for tautologically true statement which can be obtained by combining two or more statements which have already been proved for. So the answer for this part, a premise may be introduced. Introduction will always be through my rule P. So the answer is going to be A for this one. Next, the dual of the statement P. This is going to be your AND operator, and this is going to be your OR operator. This is going to be the equivalent with AND operator, and this is going to be your OR operator. This is called by the name conjunction, and this is called by the name disjunction. The basic rule for duality is that how to find the dual of any given statement. Wherever you have conjunction, replace it with a disjunction. Wherever you have disjunction, replace it with a conjunction. The other two quantities that is going to be replaceable are going to be your quantity called as true, which you replace it with false, and wherever you have false, you will have to replace it with true. So these are the four quantities that will have to be replaced to find the dual of any statement. If you people are very comfortable using your set theory notations, then conjunction can be identical with that of your intersection operator, and disjunction can be identified with that of your union operator. A true value will be identified with that of an universal set, and a false will be identified with that of a null set. So if you know the formulas in set theory, that can be equivalently handled in your logics by giving a proper replacement of these quantities. And for the case of dual, a dual is now obtained by the replacement of these. So over here we have, this is also called by the name wedge, and this is by V. This wedge is replaced with your V, and this V is replaced with wedge. So where do we find this one? So we find this one in our C, P or Q, and this true over here, when it is going to be changed for its dual, will change to its false. So a P or Q is identified here and the true now becomes false. So this becomes the dual of the given statement. Next, which one is going to be the inverse of if Q then P? A conditional statement comprises of three subdivisions, so for which we can add up to, say suppose we are having a conditional statement of the format if P then Q, then its converse is given by if Q then P. What do you mean by converse? Is flip, just put it upside down. Okay, next, contrapositive is going to be a flip with a negation Q then a negation P will be called as contrapositive. And now how about the inverse? Inverse will be taking a negation in the same direction, a negation P then a negation Q. Take negation in the same direction. Okay, negation in same direction, but a contrapositive will be a negation in a flipped version. Okay, so these are going to be three outcomes which can have out of a conditional statement. Now going back to the question, you want the inverse. What do you mean by inverse? Inverse is negation in the same direction. So you will have to take negation of Q then P. So it is going to be negation Q then a negation P. This is going to be our inverse. But negation Q is over here. Negation P is missing in this quantity. So none of the answers over here are going to be true. The answer which is the right one for this question will be a negation Q then a negation P. Next comes, which of the following proposition is a tautology? Now what do we mean by a tautology? So there are going to be one more concept which we will have to say for or check on. Tautology is nothing but a statement that has every value to be equal to true when you are taking an truth table quantity. And if you have every value in a truth table to give you false, then the statement is called as contradiction. And if your truth value has a combination and a true and a false, then you call it by the name contingency. So what do you mean by tautology? A true statement will be called as tautology, a faulty one will be called as a contradiction, and a combination of a true and false will be called as contingency. Now coming for our case, which of the following proposition is going to be a tautology? We have to check for tautology. How can we check? This can be checked either using equivalence formula, or you can use your truth table technique. Whichever is easy for you, you can follow it. So how to use a truth table for this? So the values which we can have are going to be a P, a Q, and the possible values are take truth table. Two variables are there, so you can take true, true, false, false, and variable taken one at a time, a true, false, true, false. You need to keep in mind what is going to be if P then Q. When you have a true and then followed by false, then the answer is going to be false. For all the other combinations, the other combinations will give me only true. So this is going to be the conditional statements truth table. Now what we have in the first one is P or Q. Okay, so what is going to be P or Q? So either one of them, what is going to be OR operator? OR operator means any one is true, then the answer is going to be true. Any one is true, the answer is going to be true. But over here you have it to be a false. So what happens next? I am going to take a conditional quantity with that of my P. So with this I am going to take a conditional with my P. So if this is going to be true and the next one is going to be false, then the answer is going to be false. So you are having a false over here. So this cannot be a tautology. So the first option is going to be ruled out for you. Lamont, let's move to the next option. P or if Q then P. Okay, so if I want a if Q then P. So you will have to have true for your Q and false for your P, then it is false. True for your Q and then false for your P, then this is going to be false. In all the other options, the answer is going to be true for you over here. And now this quantity is going to be taken P or. So with my P, I am going to consider this with an or operator. What is your or operator? Any one of them is going to be true, then the answer is going to be true. So true, true, answer is true. True, true, answer is true. But what happens? False, false, the answer becomes false. You have one false, so you cannot have this to be tautology. So what happens? This is also ruled out. Now we'll move on to the third quantity. If P then Q. So we will compute what is going to be if P then Q. First one to be true and the next one to be false, then this is going to be false. In all the other combination, it is going to be true, 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 true. And now what you're doing is with P you're taking an or operator. With P you're going to take an or operator over here. So with this column, true and true is going to be true. True and false, any one of them is true is going to be true. A false and true, any one of them is true is true. A false and true, any one of them is true is true. So what you have, all the values are going to be true, which means it is going to be a tautology. So what is going to be the question over here? Which of the following proposition is a tautology? So the answer is going to be C for me in this option. Come on, next move on to the next one. The converse of if Q then P. Okay, what do we mean by converse? Converse means flipping. Just you will have to flip. So converse of this will be if P, then you will have to have a Q. A P then Q is going to be a statement number C. So the option is going to be C for you. Okay, next one, dual of if Q or F equivalent to Q. How to find the dual? V is changed as which, false will be changed as true. Okay, so Q and true equivalent Q. Where do we find this? Yes, we find it over here. So the answer is going to be D. The set of premises is said to be dash if their conjunction implies contradiction. Say suppose you have H1, H2, H3 and so on, all the set of premises is said to be dash if you have the conjunction taken. Conjunction means and operator. If all of them is going to imply you a contradiction or false, then what is going to be this statement called as? Such a statement will be referred by the name inconsistent. There are going to be 4 different methods which we solve the theory of inference by, which is going to be direct method, indirect method, rule CP method and inconsistency method. So we will be using this set. You will take all the answers together, and if you arrive finally at a false, then you say that the given set of statements are inconsistent. So the conjunction, if it leads to a contradiction F, then the given set of statements are said to be inconsistent. Next, we will have the quantity which is going to be P then if Q then P. Okay, so what is going to happen over here? Either you can use your equivalent statement or you can use your truth table to check it. So as we did earlier, if you are going to go for a truth table, P under Q, so a true, true, false, false, true, false, true, false. If Q then P, we will find first, which means this is true, this is false, then it is false. The remaining statements are going to be true. And now you have to go with the if P and then if Q then P. If the first one is going to be true and the next one is going to be false, then it is going to be false. First one true and the next one false is not at all present over here, which means if Q then P has true as true, true as true, fall as true, and a fall true as true. So all the statements are going to be true. Then you call such a statement as tautology. So this is going to be true. So the answer is going to be A for you. Next we move on to the next set of statements where we have P or P. So this is something like P union P. Okay, A union A. What is A union A? It is the same as my P. So where is my answer? It is going to be in my A. Next, P or true. It is something like your P union. True is nothing but your universal set. With your universal set, if you are going to take any union of any element, you will be getting back your universal set. So the answer is going to be true over here. So you can make it to be equal to A over here. The next one we have P or P and Q. A P or Q and R. One is going to be a V operator and the other one is going to be an wedge operator. If there are going to be two mismatching operator, we will have to apply distributive law. Okay, and if you are going to have the same operator, here also V, or if you have here also wedge and here also a wedge, then you can apply associative law. Okay, so keep in mind, whenever you have the same operator, you will have to apply associative law. When you have different operator, one is V and the other one is wedge, either you can have it inside or outside, then you will have to apply distributive law. So what is going to be the distributive law? P distributes over Q and R. So it is P, V, Q and P, V, R. P distributes over Q and P distributes over R. So where can we find this statement P over Q and P over R over here in B? So the answer is going to be B. Next, if Rama works hard, he will get success. P is denoted as Rama works hard. Q denoted by he will get success. This is going to be if and then statement. If and then statement are called as conditional statements. So how to denote conditional statements? By if P then Q. This is how we denote a conditional statement by. So Rama works hard is denoted by P. So if P, then he will get success. Then is a hidden word over here. If is present means the second part is going to imply a then for us. So then what will happen? He will get success is denoted by Q. So if P then Q, where do we find it? In our answer B. So this is going to be our answer. So we will move on to the next set over here. So what happens over here? The premise may be introduced in any point of the derivation. A premise may be introduced using my rule P, introduction of premise. Okay, so this is going to be my answer for the ninth one. If P then Q is logically equivalent to P then Q is equivalent to a negation P or Q. So this is going to be the important equivalence relation which we will be using for solving many of our problems. So it is better to by heart this. If P then Q is equivalent to not P or Q. So not P or Q, where it is present, not P or Q, it is present in my A. So this is going to be my answer. The next one, I want the dual of this given statement. What do we mean by dual? Replace your P and this wedge will be replaced by V and Q. I'm sorry for it. So this will be P and Q will now be replaced as a P or Q, and this or will now be replaced with which and an R. Okay, where do we find this one? So we find it in dual of this is going to be P or Q and R over here in D. So P or Q, this we will now change to which over here, and so this is your answer. Next we need the quantity negation P, and if P then Q, then negation Q is N. So I need to solve this quantity either using truth table, or you can solve it using the equivalence relation which we just now saw. So a negation Q, and if P then Q will be rewritten as not P V Q. Okay, so this is my first part, and then you have a negation P. So let me solve for this. This is going to be, as we said, one is going to be wedge and the other one is going to be V. So we can use your distributive law over here. So it is negation Q and negation P, or negation Q and Q. So this is going to be my quantity, and this will imply a negation P over here. Now a negation P and negation Q and Q, it is something like my A intersection in wedge is going to be intersection. Negation Q is going to be A bar. A intersection A bar, is anything common to A and A bar? No, null set. How to denote null set? By, in your logic it's going to be F. So this will become F. Now using your quantity negation Q and negation P, your De Morgan's law can be stated this as your negation of your Q, this wedge will now become V or P. Okay, so this is going to be my quantity, and then you have a negation P. Now this is something like my quantity A, and you take V over here, which is union, and my phi is going to be null set. What is A union null set? It is going to be A. So when you take V with this F, what you have is negation of Q or P, and then a negation P. So this is what we have over here. So if you are going to apply if P then Q to this quantity, then it is going to be negation P. So it is negation of negation Q or P, or this is going to be or part under Q, so it is going to be negation P. This negation can be cancelled off, so you have Q or P or negation P. All the symbols are the same, so I can flip the brackets using my associative law, as we said in the last slide. So when I combine Q or P or negation P, it is going to be A union A bar. What is A union A bar? A union A bar is going to be your universal set. So this is going to be true. So this is going to be true, a Q or true. So something like my A union and true is going to be universal set. What is common to a set and a universal set? It is the same universal set. So Q or true will be equivalent to a true, which is going to be our universal set. So what is this true? True is implying me and tautology. So of the given quantities, what is going to be the answer? The answer is going to be tautology. Okay, now we move on to the next set of MCQs. Now what is going to be the converse of my statement? Converse is nothing but flip. What do you have to flip? A Q then negation P. This is going to be my answer. Where do I find this converse? I have a Q and negation P over here in my B. So B is my answer. The next one, the dual of P or Q then R. So this is again a if P then Q statement, which is equivalent to negation P or Q. So we will first replace this as a P or Q with that of R is equivalent to negation of P or Q and or R. Okay, so this is my quantity. So when I have it, you can expand this as negation of P V will now become which? Negation Q or R. So this is going to be my statement. What you want is the dual of it. What you will have is dual is got by flipping a negation P will be as such, a wedge will now become V, a negation Q will be as such, a V will now become wedge, and this will be your R. You can take your negation sign outside by De Morgan's law. So you will have P, this V will now become wedge, a Q and wedge and R. So try chasing for this one in your answer. Where is it? Okay, over here. So my answer is going to be C, negation of P or Q and R. Next one, the negation of the statement I did not have strange dreams. Okay, so if P is a quantity, its negation is given by not of P. Whenever this is becoming true, this becomes false, and whenever this is false, this will become true. You have a did not have dreams. So what will happen? You will have to change this I had dreams. So where you have the quantity I have dreams, this is present in your A. Okay, this does not mean any of these things. Peaceful dream, I never sleep, dreamless, all this are going to be irrelevant to the negation of this answer. Please don't go for them, though they logically may imply one after the other. What you want is going to be the negation. Negation means not of the answer, not of not. Okay, not of not is going to be negation of negation P will be equal to P. So you want the original one. What was the original one? I have a strange dream. 12th one is going to be which of the following proposition is a tautology? This one is what we proved in our slide 1 itself, and P or if Q then P. So this one is going to be the same as my C. So we are done with this set. Let us move on with the next one. The premise may be introduced at any point using my rule P. So this is my A. The symbolic form of if Raja takes Max, let me denote this as P, or Mahi takes English, let me take this as Q, and Arun takes Hindi, let me take this as R. If a part and a conditional part, okay, but so it is a if P then Q type of statement, but the if part contains an or operator over here. Or is denoted by V. So a P or Q and then and R. So this is how the statement has to be framed for. So where is it present? In your A. So this becomes your answer. Okay, number 11, a mathematical induction is used to solve the statement which involves only. So as n is going to be the term for which we give induction, we normally fix your n to be greater than that of 0. We now take values like 1, 2, 3 for fixing. So it is normally a positive integer for whichever we solve for. Okay, we solve for. Though the statement may be true for any natural numbers, what do we take and solve for? We put n is equal to 1, we put n is equal to k, and we put n is equal to k plus 1, where all of them are going to be positive integers. So the answer is positive integers. Okay, now next moving on, a P and if P then Q is equivalent to. Okay, now P and if P then Q. How to write if P then Q? A negation P or Q. Now this is going to be V wedge and this is a V, two different statement. So we will use distributive law for this. P and negation P or your P and Q. So this is going to be my statement. P and negation P. So something like A intersection A bar. What is common? Null set. So null set is going to be F or a P and Q. Okay, and again a null set with or null set union A. What is going to be common union of A and null set? So this is going to be A. So when you take F with this, you will have P and Q. So where do we find this answer P and Q? In our D. So this makes this as our answer. Okay, now moving on to the next one, we have the statement negation P is going to be P or negation P. What is going to be P or negation P? P union P bar. Okay, what is going to be union of both these statements? It is going to be universal set. What is universal set denoted in our logics by? It is going to be true. So 2 is nothing but tautology. So the answer is going to be our B. Next, the dual of the statement negation P, then if P then Q will be not P V Q, and again a negation for this, negation not of not P V not P V Q. So this is going to be my not of not P will give me P V not P V Q. So this is also V, this is also V, the contents are going to be the same. So I can take this to be the answer, but what I need over here is going to be the dual. What is meant by a dual? Dual is flipping the operators. This V will become wedge for me, and negation P, V will now become wedge for me. So P wedge, negation P and Q. So this is going to be my answer. So am I able to find this somewhere? A negation P and Q, here it is, but this P is not given in the direct form. Negation P and Q, P or is here, so this is not the right one, but I can write this P as not of not P. Negation of negation P is going to be P. So double complement, negation of negation P. So the dual will now become your option number B. Now the contrapositive of if P then Q will be, if P then Q will be negation Q then negation P. This is my contrapositive. So this is being given as negation Q then negation P in my option number C. So this becomes my option. Next comes for each n belonging to capital N, 3 to the power of 2n minus 1 is divisible by. This is going to be a statement in mathematical induction, which we can start proving by providing any natural numbers beginning with n is equal to 1. If I put n is equal to 1, this will become 3 to the power of 2 into 1 minus 1. So 3 to the power of 2, 3 square makes it as 9. 9 minus 1 is going to be 8. The statement will be true for n is equal to 1, which is going to be 8. So the answer is going to be A, which is going to be 8. I hope that this set of quantities, which is going to be solved using your mathematical logics, have given you an insight on how to handle problems now. I wish you an happy learning, and please do keep learning. Thank you very much.